In this video, we're going to talk about topic 5D, factoring trinomials with the leading coefficient. The first problem we're going to look at is 6x squared plus 5x minus 4. So when we want to factor this, we first want to look, is there a GCF? Is there something that all three of these terms can divide evenly? And it looks like there is not. So the second thing we think about is how this is going to break down into two binomials being multiplied. So the first piece of each of these binomials is going to be what multiplies to be 6x squared, and then the last piece of each of these is what multiplies to be the negative 4. The positive 5x comes in when we multiply all of those things out together. So what we want to do is first check what can multiply to be 6x squared. There are a couple of options. Could be 6x and 1x, could be 2x and 3x. Typically, with problems like this, if it's relatively small numbers, you want to choose the relatively smaller numbers. So instead of the 6 and the 1, because 6 and 1 are kind of far apart, we would want to use 2x and 3x just as our first guess and see if that works out. The next thing we want to think about is what can multiply to be negative 4. And eventually, we're going to have to add to be that positive 5. So if I want to multiply to be negative and add to be positive, I need one positive and one negative number. I have to have that. So I'm going to try for what can multiply to be negative 4, maybe 4 and 1 first, and I'll choose the 4 to be negative. So I'm going to put a negative 4 over here and a positive 1 over here. So it's not enough just to throw these numbers in there. We actually have to check and see if they do multiply out. So we're just checking our work to see if this is the correct answer. So when I multiply out, I will get 6x squared plus 2x minus 12x minus 4. So these middle terms will combine to be a negative 10x, which is not the positive 5x that we need for our problem, so this is not going to work. So we can scratch that and try something else. So we just tried the negative 4 and the positive 1. What if we try negative 1 and positive 4? And what if we switch where they are? So now when I multiply this out, I'll get 6x squared plus 8x minus 3x minus 4. When I combine these like terms, I get 5x in the middle, which is exactly what it needs to be. This means that our final answer is the second one that we tried. So that's going to be the 2x minus 1 times 3x plus 4. That is our final factored answer. The second problem we're going to try is 8x squared minus 55x minus 7. So one thing that I noticed about this one right away is that 55x is kind of a big number, and that means I almost want to play with the bigger numbers rather than breaking it down to smaller numbers. So first we check for a GCF. Is there a greatest common factor that all three of these can divide? And the answer to that is no. Next, we try to break it down into our binomials. So we think for the first piece, what can multiply to be 8x squared? And in this case, because 55 is such a big number, I think I want to try 8x and 1x as opposed to 2x and 4x, because those are going to be relatively small and we probably won't get that big difference in between. And I could be wrong, but we'll see if this works out. The next thing we want to do is think about what can multiply to be our negative 7. So what's nice about 7 is it's prime. That means that we can only do 7 and 1. And we could do positive 7 and negative 1, or negative 7 and positive 1. And it does matter the order. So again, I'm thinking this big 55, I kind of want the 8 to be across from the 7. And I'm going to make that one negative, and I'm going to make a positive 1 with the 8. That way those won't get multiplied. So this is my first guess, and let's check and see if it works out. If I multiply out, I get 8x squared minus 56x plus x minus 7. And those two like terms in the middle, if I add them up, that does give me negative 55x. So this is going to be our final answer. So our final answer here is the factored 8x plus 1 and x minus 7. Done.